Ever pondered why a magnet falling through a copper tube seems to defy gravity? It all comes down to a fascinating principle of electromagnetism called Lenz's law. Lenz's law, named after the German physicist Heinrich Lenz, who formulated it in the early 19th century, is a pillar of electromagnetic theory. But what does it say exactly? It predicts the direction of induced current in a conductor due to the change in magnetic field. In other words, it's all about how a change in magnetic field can create or induce an electric current. But Lenz's law adds a twist, a unique characteristic, if you will. It states that the induced current will always flow in such a direction that it opposes the change that produced it. Sounds a bit complicated, right? Let's break it down with an example. Imagine you have a loop of wire and you're moving a magnet towards it. As the magnet gets closer, the magnetic field through the loop increases. According to Lenz's law, the loop doesn't like this change. So, it induces a current that creates its own magnetic field, a field that opposes the increase. It's like the loop is saying, no, I don't want more magnetic field here, thank you very much. Now, if you start to pull the magnet away, the magnetic field through the loop decreases. Again, the loop resists this change and induces a current. But this time, the current creates a magnetic field that tries to keep the original field from decreasing. It's as if the loop is saying, wait, where are you going? I was getting used to that magnetic field. This fascinating law is not just a theoretical curiosity. It has profound practical applications. It's the principle behind electric generators, where mechanical energy is converted to electrical energy. It's also the reason why metal detectors work, and why an aluminum can get crushed in a coil of wire when a high voltage is applied. To sum up, Lenz's law is a cornerstone of electromagnetism. It describes how a change in magnetic field induces an electric current in a conductor. But more than that, it tells us the direction of that current will always be such as to oppose the change that caused it. It's a law that says, I don't like change, and I will do whatever I can to resist it. So the next time you see a magnet falling slowly through a copper tube, remember it's not defying gravity. It's just Lenz's law in action, a quiet yet powerful testament to the intricacies of our universe.